over here we have g of x, which is really f of x, and then we have h of x, which is really g of x, and then also we have p of x, which is really supposed to be h of x. But since I'm using GeoGebra, GeoGebra changes it because they're quadratics. As we see, by adding, because we are adding g of x to h of x to create our p of x, we have half parabolas or half a parabola all over the place. If we change the slope of f of x, we get the slope of x cubed, as we see right here. And then we have half parabolas for the rest by adding x squared plus x to the 2.3. And then the dips become bigger with the smaller, this number over here, negative 3.3x becomes. But if it becomes bigger, it becomes a straight line. It straightens out more. The y-intercept moves it down the y-axis like always. But what happens if we move the slope of h of x? Well, it changes. Oh, let's see if I can catch it right here. As we can see right there. Now we have a parabola here, a parabola here, the x cubed function graphed right here, and we have the blue h of x function going like this and like this, never going to touch the x-axis. I mean the y-axis, sorry. And if we move the y-intercept of h of x, it moves up and down. The graphs are getting a lot different than just the linear lines because they are quadratics. But what would happen if we were to, instead of add g of x to h of x, we were to subtract g of x to h of x? Let's see. So now, as we see up here, they are being subtracted from each other. Graph really did not change. It still looks the same. We move things around. The graph is being changed. Now we have parabola, parabola, half a parabola, and what happened to p of x is it's a straight line now. When we change the y-intercept, now we're actually getting some movement right here. Now it has become the x cubed function again. Let's change the slope a little bit more. Now we're getting big whoops. And then the line here of p of x is never, let's see, it's never going to touch the y-axis, but it has this funky whoop right here, and then it becomes this line never going to touch. And neither is h of x right now. H of x on both sides, here and down here, are never actually going to touch the y-axis. They'll come as close as they can, but never physically touch right now. And right there too. By moving it, it goes up and down the y-axis. So that, it's still all crazy parabolas and never touching the y-axis, and that's for subtracting. Well, what would happen if we actually multiplied the two functions together? Now that we have multiplied them together, as seen right here, so we've taken g of x and multiplied it with h of x to create our new p of x. Let's see what happens when we change the slopes. We have a big parabola for g of x, and it looks like p of x is swooping like this. And then h of x is still never touching the y-axis. Well, let's change the slope of h of x. Now we have half parabola and a parabola facing down and then up. But what would happen if we actually now, instead of just multiplying them and getting what we are getting right now. What if we divided the two? Let's find out. And now we've taken g of x and divided it by h of x to create this new p of x, which is right here. And we have the parabola here, a straight line here, and then it whoops here. So what would happen if I change the slopes again? We have a parabola, change the slope of h of x. Let's change this. The slope is now moving. What happens if I change the slope here? Now they're becoming more of straight lines. The y-intercept is just going to move where the y-intercept is on. Move them down and over. -5, it's at -5 now. Overall, we have seen the graphs completely change over and over because of the fact of we are multiplying, dividing, adding, or subtracting. We've created tons of different parabolas, tons of x cubed graphs, x squared graphs, things we've never seen before. We were not seeing any of this with just the linear functions. Because they are quadratics, a lot more is happening. When you add all these together, you have to add both of them together to create the new function